Alright, so some of you may be wondering why this extra loop here. Now, these projects have a tendency to add to themselves as we go. So I have left an extra loop in my power conductor in the one box up here that splits off. You can leave these. You'll notice here I did not. You do not have to leave extra loops in boxes, but you could imagine that if I wanted to tie into this black wire in this box, if I simply cut it, 4-inch wide box, I'd only have two 2-inch tails. I do not have a workable length of conductor there, so therefore I've left a loop. That way in the future, if I have to cut this, I have my two 6-inch tails. Now, you're ready to be marked for this. This is step one. Get it to this point. Bring this to your instructor and get this graded. We're going to go over all of your connections. Now, what exactly all are we looking for? We're looking for adequate length, a minimum of 150 millimeters of free conductor where it enters the box. Anything, any connection. If you are going to any type of connection, whether it be a moret or a terminal, you need a minimum of 6 inches of conductor. Now, you do not technically need jumpers this long. I like to leave 6 inches because if you're working in a switch box, sometimes a little 3-inch jumper is not quite big enough to get this moret out of the way. So I like to leave longer ones for that reason. Now I have left these a little long on some of these. It's minimum 6 inches. I don't want to see any more than 9 inches in a box. That's a little bit too much conductor to try and cram it all back in there. But between 6 and 9, some instructors will want you to stick to as little as 8. 6 to 9 is adequate. Minimum 6. Less than 6, it's a code violation. You will have to redo it. Now, when you are bringing this up, there are a few other things that we are going to be looking for. Your connections. Your connections need to be done in a clockwise manner. They need to be minimum 3/4 of the way around the screw, under the screw. They need to be stripped so as to have no copper leaving the device. Preferably, your copper ends on the device or even away from the edge, such as this one. But it's got to be stripped long enough that you don't have any of your insulation under the screw connection. The screw would then be tight on this dimension, not on the copper conductor underneath. The other one that you will notice, and this is kind of a slight code thing, you are allowed to, when you have a wire binding terminal such as this, you are allowed to have anywhere up to a maximum of a 10 gauge conductor going down one side of a containment type screw connection. So where that box has the raised shoulders, that conductor can't slip outside of that. In fact, if I loosen this just a little bit, you'll notice that my conductor is loose in here, but it can't come out the side. Okay? You are allowed to have a single conductor under one side of that screw. You do not need to loop it. One of the other things about the bond conductor is you do not need to go from box to box to box to box. Metal conduit in and of itself is an electrical connection between two metal boxes using metal connectors. So you really only need to bond where your connection conductor comes in and your bonding conductor for any receptacle or any device on your board that will have a bonding screw. Alright, once you've had this step graded by your professor, you've corrected any minor defects that need to be corrected, you can then go ahead and close them up. Now, there are two types of tightness in electrical. There's tight, I never want this to come loose, like electrical connections, and there's snug. Plastic things get tightened up to be snug. You don't want them to be loose and wiggly, but you don't want to break them. Alright, one thing to do before you go making too much of a mess. You saw through the whole video I was collecting all my wire strippings and my garbage. That can go straight into the garbage or your pocket. Take it home or put it in the garbage. But please don't leave it on the desk or my floor. Okay, so just doing a simple resistance check. You can either be on your ohms reader or your diode check. And we can turn on our first light bulb and we will see that we have a resistance there. We can turn on our second light bulb and we'll see that we also have a resistance. Since these are in parallel with each other, if I add in a second one, the total is less than the least, so it's going to drop. Take that one out, goes back up. I've verified my circuit. One other thing that's good to do is to also verify that your black conductor is not touching your ground conductor anywhere in your circuit. I have no connection. And the last thing you want to do at the end is double check that your meter is working. Double check that your leads are still working. If your meter shut off halfway through while you were testing power, well, it could still be on. Alright, now at the next part here, if your next drawing is already checked off and has had a mark applied to it, then you could carry on wiring for that. Pre-wire, bring it up and show us. If it is not, then you will need to make sure that your drawing is done. You can either take this and put this board back up in the rack, put your bucket back in the back room, and have a wonderful rest of your day.